Hi, this is Mrs. Young, and this video is on volume of pyramids and cones. For our bell ringer, I'm going to have you practice finding the volume of three different shapes below. I would like you to round it to the nearest tenth if needed. Remember that the general formula for volume of shapes, our volume is equal to, of our 3D shapes, it's the area of the base times the height. So in some problems, like the first one, they'll actually give you the area of the base. But in some of the other problems, you have to actually calculate the area of the base and then multiply it by the height. So again, volume is base times height. Go ahead and pause the video and see if you can come up with the volume of these three shapes. Okay, so for number one, the square prism has a base area of 189 and a height of 21. So 189 times 21, you should have a total volume of 3,969 feet cubed. Again, remember, volume is your unit to the third power. Number two, we have a regular hexagonal prism. So that means that our base is a regular hexagon. It says that the edge length is 24. So if that's 24, that means half of that is 12. And then your apothem is 12 root 3. Remember that you're creating a little 30, 60, 90 triangle there. So the area of a regular polygon is 1/2 times the apothem times the perimeter of the base. So that's 1/2 times 12 root 3 times 144. Again, 24 times 6 is 144. So this part represents the area of our hexagon, and then when we multiply it by the height of the prism, that gives us our total volume for the hexagonal prism, 14,964.9. And then number three, we have a cylinder with a diameter of 16 and a height of 22. Again, if the diameter is 16, we know the radius is 8. The base is a circle, pi r squared, and then multiply that by the height. So that's how you get 4,423.4. So again, those were just practice of our previous lesson on volume. Today we're going to talk about volume of pyramids and cones. So I'm going to have you start by writing down your formula for the volume of a pyramid. The volume of a pyramid is, again, area of the base times the height, but it's 1/3 of that because your shape is going up to a point. Again, if you had a regular, let's say this was a rectangular prism, right? It would be much bigger volume, but because it's going up to a point, it's only 1/3 of that value. So it's 1/3 times the area of the base times the height. Just like we talked about with cylinders and prisms, you can even be talking about oblique pyramids, ones that are tilted or slanted. Just make sure your height is perpendicular to your base. So again, make sure you have that formula jotted down. Okay, so let's go ahead and try a practice problem. It says find the volume of a rectangular pyramid with a length of 11, width of 18, and height of 23. Again, this one's pretty easy because your base is a rectangle, 11 by 18, multiplied by the height. But then don't forget it's 1/3 times the area of the base times the height. So when you plug that into your calculator, again, this one's super easy. You should come up with 1518 as your volume. So again, that's a really basic, simple rectangular pyramid. The next one we're going to look at, this one, we're going to look at this one together. It says find the volume of the regular hexagonal pyramid with height equal to the apothem of the base. So again, if it's a hexagonal pyramid, we know that the base is a hexagon. So first, let's just write down our formula. The volume is equal to 1/3 times the area of the base times the height. Since our base is a hexagon, let's just go ahead and sketch a little hexagon, regular hexagon. Oh, no, mine's not very good. Okay, so there's my regular hexagon. I know that it's 12 feet on each side. I can go ahead and draw the center of that hexagon, and there's my central angle, and draw in the apothem, right? This is creating a small 30, 60, 90 triangle. So if that whole side is 12, half of that is 6. That means that my apothem is 6 root 3. Again, remember, this is a 30, 60, 90 triangle. So the area of our regular polygon is 1/2 times the apothem times the perimeter of the base. So that's 1/2 times 6 root 3 times, again, the perimeter of my base, that's 12 times 6, which I think is 72. So there is the area of that hexagonal base. So back to our volume formula, this is going to be 1/3 times the base, which is our regular hexagon, 1/2 times 6√3 times 72. And then our height is equal to the apothem. So it's the same as the apothem, which is 6√3. So again, this middle section represents our hexagonal base, and then this is the height of our pyramid. Go ahead and plug that into your calculator and see what you come up with. Hopefully your radicals cancel out, so it's a nice whole number answer. There's no decimal here, so it's 1,296 feet cubed. So 1,296 feet cubed for the volume of this hexagonal pyramid. Okay, so that's our pyramids. Next, we're going to jump over to cones. So our formula for a cone is 1/3 times, again, the area of the base times the height. But in a cone, our base is a circle. So the area of a circle is pi r squared. So our volume for a cone is 1/3 times pi r squared times h. Make sure you have your formula written down. Again, this formula relates to either right cones or oblique cones. Doesn't matter if it's tilted or slanted or straight up and down. Just make sure that your height is perpendicular to your base. So make sure you have that formula written down. So next we're going to go ahead and try a couple of cone practice problems. It says find the volume of a cone with the base circumference 25 pi inches and the height 2 inches more than twice the radius. So again, if our circumference is 25 pi, we know the circumference of a circle is 2 pi r. So that's equal to 25 pi. And if I'm trying to figure out what my radius is, again, 25 divided by 2, my radius is 12.5. Now it says up here that the height is 2 inches more than twice the radius. So the height is 2 inches more than twice the radius. So that's going to give you a height of 27. So now we have our height and our radius, and we can go ahead and figure out the volume of this cone. Again, the volume of a cone is 1/3 times pi r squared times h. So I can go ahead and plug in a radius of 12.5, that's squared, and then my height is 27. Notice that it says in terms of pi and rounded to the nearest tenth. So when you want it in terms of pi, you're just going to multiply 1/3 times 12.5 squared times 25 to get the answer in terms of pi. So when I did that, I got 1,406.25 pi. Again, that's my answer in terms of pi, and that's inches cubed. And then if I want the answer rounded to the nearest tenth, I would take the 1406.25 times pi, and you should come up with, check on your calculator with me, I got 4,417.9 inches cubed. So again, volume of a cone and volume of a cylinder, sorry, volume of a cone and volume of a pyramid both have a 1/3 in their formula because they're going up to a point and they're smaller than the prisms and cylinders. The next cone practice problem, it says find the volume of a cone in terms of pi and rounded to the nearest tenth. One thing you'll notice here is this example, they gave us a slant height of 34 and you have to figure out the actual height. Well, I can see that we have a right triangle here, so you're going to use some Pythagorean theorem to figure out your height. And then once you have your height, go ahead and figure out the volume of this cone. So go ahead and pause the video and see if you can figure out the volume of this cone. Pause it. So hopefully you came up with, in terms of pi, an answer of 2,560 pi. And then rounded to the nearest tenth, you should have 8,042.5 centimeters cubed. So again, double check your answers and see if you got that one right. Okay, finally, my last couple problems here are on composite figures. So there's two different composite figures, and I'm going to have you practice finding the volume of each. Real easy to find volume of composite figures. You just find the volume of each shape and add them together. So like in number one, you would find the volume of the cone on the top, the cylinder in the middle, and then the cone on the bottom, and add those three volumes together. Or like in number two, you're going to find the volume of the cone on the top and then add it to the volume of the cylinder. So go ahead and pause the video and see if you can find the volume of each shape. Okay, so for the first shape, the top cone, that one I have a volume of 5,145 pi. The cylinder, I have 15,435 pi. And then the bottom cone, I have 5,880 pi. And when I add those together, you should have a total volume of 26,460 pi. Again, for the cones, it's 1/3 pi r squared h. And then for the regular cylinder, it's pi r squared h. Again, if this is 35 and this whole distance was 70, then we know the height of this cone has to be 70 minus 35 gives us 35. So the height of that top cone was 35, the height of the cylinder was 35, and the height of the bottom cone was 40. Okay, and then the other problem that you had to practice was the cylinder and the cone on top. So for this one, I have, in terms of pi, 10,800 pi. So again, the cone on top had a radius of 12 and a height of 9. The cylinder on the bottom had a radius of 24 and a height of 18. And you just add those two volumes together to get your total volume. So that is our lesson for today on volume of pyramids and cones. Your homework for tonight, maybe I'll write that down right here. Our homework for tonight, again, I've slightly altered it or changed it from the stamp sheet. So it's going to be on pages 43 and 44. I'm going to have you do numbers 13 through 27 and 32 through 38 even. So 13 through 27 is all, and then 32 through 38 is the even. So again, I've slightly altered this from our stamp sheet, took a few problems out. So again, that's your homework for tomorrow. Make sure that you get your homework posted in Google Classroom. Take a picture with your Google Chromebook, or take a picture with your scannable app if you'd rather. Thank you. Stay safe and stay healthy. Bye, guys.